Welcome to this puzzle session. Here is the problem. 15 chairs are evenly placed around a circular table. So this is a circular table and there are 15 chairs. Let me draw them in pink. And they are evenly placed. So the angular distance between any two consecutive chairs is the same. On the table are name cards of 15 guests. So 15 guests are to arrive and their names are written in some order, in some way, on these 15, again, evenly placed positions on the table. So let's say the names are C1, C2, C3, and so on. So these are the names of the guests. After the guests arrive and sit down on the chairs, it is found that no guest is sitting in front of his own name card. So the guests are somehow dearranged. They just casually seated themselves without looking at the name cards, and it so happened that no one was sitting against the correct name. Show that the table can be rotated so that two guests are simultaneously correctly seated. So one may rotate this chair by whatever this angular separation is. It's 2 pi by 15. So one may rotate it some number of times, and the problem asks to show that there is a rotation which has a property that at least two guests will be seated correctly. All right, so let's prove this. Let us name the guests by these numbers, 1 to 15, the most easiest naming scheme. And we define for a position P of the table, meaning you rotate the table, each rotation I'm, writing as a position. The table can be in 15 different positions. So for each position P of the table, we define DIP as 1 if the ith guest is correctly seated when the table is at position P, and 0 otherwise. So we are merely recording for each position which guest is correctly seated. That's all. We're just assigning a number to it. Okay. Similarly, we define NP as the number of guests correctly seated when the table is at position P. All right, so these definitions are very simple, but here is the thing. The problem asks to show that there is a position such that NP is at least 2. So this symbol here just means there exists. Nothing more and nothing less, just a shorthand. Okay, and one must realize that the problem is precisely asking us to show this, that there is such a P. All right, so here is the crucial observation, or maybe a very simple one. So NP is nothing but this number. Right, so what is the right-hand side? The right-hand side is the total number of i's for which DIP equals 1, which is same as the total number of i's for which the ith guest is correctly seated, which is same as the total number of guests which are correctly seated, which is NP. So this equation should be obvious. And here is the main, move that allows for the solution of the problem. What we do is we sum over all positions, both sides. Right. So this P runs over all positions, meaning it runs on a set of 15 things. There are only 15 different positions that the table can be in. And on the right-hand side, we will switch the summations. So this becomes like that. And let me put a bracket here. So just look at this number. This is counting how many positions are there for which DIP is correctly seated. But a moment's thought will tell you that this number is actually 1. There is exactly one position for which the ith guest is correctly seated. The guests are not moving. Once they are seated, they are seated. All we are doing is rotating the table. So the right-hand side is nothing but 15. And the left-hand side is as it was. Okay. But the left-hand side we can write as np naught plus summation p different from p naught, np equals 15. Where what is p naught? P naught is the original position, the initial position of the table. And by hypothesis, by what is given in the question, np naught is 0. And therefore the left-hand side is just this, which is 15. And now note that these are 14 non-negative integers. Which sum up to 15. Thus, there must exist some p star such that np star is at least 2. Because otherwise, if for each p this was at most 1, we would have this number is at most 14, which would contradict this equality. Therefore, there must be a p star, some particular p, for which this value is at least 2, greater than 1. And that's it. That was the goal of the problem. And that finishes the solution. So as usual, like, comment, share, subscribe. I also have Patreon. The link is in the description below. Thank you for listening, and I'll see you next time.